So what happens when a microcontroller starts? So there are some steps which is being performed by the hardware itself when a microcontroller starts. So when microcontroller starts, either you did the power off and then power on, either there is some reset, soft reset or some hard reset or reset due to watchdog. Any of these scenarios, your microcontroller will basically start. So what will happen whenever microcontroller starts? Two things is performed by the hardware. First thing is the MSP, means the main stack pointer. It will load with the content at the address 0000. And the second thing what will happen is PC, means program counter. Program counter will be loaded with the content available at the address 004. So this is what happens. So this is purely done by the hardware. We don't have a software influence here. Now if you will see in our microcontroller, currently we don't have any address which starts with 00. So we have two memories, one is the flash memory, one is the RAM, and flash starts with 800, RAM starts with 200. So what happens in the STM32F4, there is something called a memory aliasing. So in the memory aliasing, this memory is by default mapped to the start memory of flash memory. So 000 address is mapped to the 0x8 all zeros, means the starting address of the flash memory. So this aliasing happens. Now if this aliasing is there, then by default this PC program counter is trying to access this address is mapped to here at this address, means 08000004. This memory aliasing happens. Now it means at the time of startup, the main stack pointer MSP will be loaded with the content available at memory address 8000000. Now this is our responsibility as a user, this is our responsibility to keep the correct content, the proper content at this address, the starting address of the flash memory. So what MSP is? Main stack pointer, means we should keep the address of the stack. And what is the address of the stack? That is nothing but the end address of the RAM. Why? Because in the STM32F407, stack grows downward. So since the stack grows downward, in the RAM we will start the stack from the end address. So from this address, and then it will grow downward. So that's why the last address or the end address of the RAM should be available at the flash memory starting address. We should have this address. So MSP will load with the last address of the RAM, which is a valid stack pointer. And also if you will see, this area is nothing but the interrupt vector table. Okay, and in the interrupt vector table, what we have? We have the addresses. We have the address of reset handler, we have the address of NMI handler. So different ISR's address we have. And then in our memory mapping, what we do is after the IVT, we keep the reset handler, and after the reset handler, the user function, user defined functions, whatever we have. NMI handler and hard fork handler, these handlers are nothing but the ISRs, interrupt service routines. So if you will see, according to our design, this reset handler, this is pointing to here. So this reset handler member have the address of this function, reset handler function basically. Okay. Ultimately, what will happen once we make sure that we have kept the E stack properly at the starting address and then the reset handler properly, after the E stack, then the final result will be in your MSP. What will be there? The E stack. E stack will be loaded to your MSP and your PC reset handler. Reset handler will be loaded to your PC. So this is the final outcome. So this thing is mainly done by the hardware. As a user, we have to take the responsibility, or we have to make sure that E stack and the reset handler are at the proper address. Now we will see how to keep the E stack at the proper address, how to keep the reset handler in the proper address, so that at the time of boot up, microcontroller will not face any issue. So this part we will see now. So this is the part where the linker comes. So using the linker only, we do all these things.